Welcome to the further demonstration of grid impedance estimation through grid forming power converters. So coming to the grid forming one, there are two different grid following and grid forming techniques. So in that grid forming, nothing but adjusting the modulated voltage with respect to the voltage at the point of common coupling. So here the point of common coupling is at the section of distribution common point and the customer grid section and power distribution section point. So now the bulb is going to be the PCC. At this point we are going to checking the voltage and current levels that will done by the PIC microcontroller continuously, and from there we are going to provide the signals to this inverting section. Means we are going to designing the grid forming technique in the solar grid or wind grid. So from the output from the solar panel grid is connected to this battery which is rechargeable, and from there we are going to forming the grid with the help of this HVS circuits. So this can be done with for the 3-phase or a single phase. Now we are implementing the grid forming technique for the single phase with the help of these two MOSFETs by providing the 50 Hz frequency signals to these MOSFETs. From there we are going to converting the 12 volts DC to 12 volts of AC. And the MOSFET purpose is we are going to convert the 12 volts DC to 12 volts AC with 2 amps currents. So generally the microcontroller can't handle the more current, that's why we are generating the signals from there, and that signals given as input to the gate of this MOSFET, and it will get the signal of 12 volts AC with 2 amps of current, and that will be step up to the 230 volts as a PCC point for the customer distribution end, and that will be done with the help of the step up transformer, which is 12 volts AC to 230 volts of AC will be step up, and that is directly distributing to the customer section. And here, in order to recharge the battery in real time, we can place the grid of solar or a wind. It's a non-renewable source, renewable sources. And now we are demonstrating with 230 volts AC input to the step down transformer. Now the battery is charging with the help of the transformer. So here we are using 230 volts to 12 volts of AC step down transformer, that is input to the regulated power supply of charging controller, and this is used to convert the 12 volts of AC to 230 volt 12 volts of AC to 12 volts of DC, pulsating DC, and with the help of this capacitor we are going to converting the pulsating DC to pure DC voltage. So that is the main charging voltage for our battery, that is through these two diodes. So from these diodes we are using these diodes as a unidirectional current flow. Whenever the battery is fully charged, in order to protect the charging circuits, we need to block the current flow from the battery to the charging circuit. So that will be done with the help of these two diodes, and the LED will show the status of the charging. So the battery will get fully charged in a duration of 8 hours maximum. After that, automatically the charging controller will block the current flow in order to protect the battery from overcharging. Coming to the battery ratings. So here we can see the 6 batteries. In that, 3 batteries are in series, that 4 volt 1 amp batteries. Each battery have 4 volt 1 amp batteries. So these 3 are in series, so we'll get 12 volt 1 amp, and this one is a 12 volt 1 amp. So both are in parallel, so we'll get 12 volts 2 amp output. So through the switch we are providing that to the microcontroller, which is main forming the grid, and the operating voltage for the microcontroller is 5 volt. For that purpose, we are making use of 7805 regulator, which will take 12 volts DC input and provide us the 5 volts constant DC output. Once we provide that, the main concentration of the microcontroller is maintaining the 50 Hz clock frequency whenever the fluctuation occurred. So it's keep on providing the 50 Hz frequency that was connected at the C6, C7 pin of our PIC16F72 microcontroller. When we on that, it automatically provide that. So there we can see one more like 555 timer IC. So the main purpose is there any distortions occurred is harmonic generated, so it will keep on providing the unstable multi vibration signals that will be done to this BC547 transistor. So this potentiometer is used to control the frequency. So as we have set for the 50 Hz, we can change that also by rotating that. So don't change that, as a transformer will provide the malfunctioning and generate the reverse harmonics one. Right. So coming to the grid impedance, the main purpose of the grid impedance is estimation of voltage to current at the right. So the main grid impedance here is like estimation of voltage to current interfacing of two steady state operating points. The two steady state operating points is before and after distribution. So before distribution, and after distribution we are going to checking the voltage and currents. So that is continuously done with help of the 555 timer IC. So let us see the demonstration directly when we on this. So the controller start producing the signals, and the 555 timer will start comparing the voltage and currents, and based on that signals we are going to provide the trigger pulse, astable multivibrator. So as the 555 timer can be operated in three modes. One is astable and bistable and monostable. So astable nothing but continuously it keep on generating the signals to the transistor to maintain the voltage currents at the steady state points and before and after distribution.